Hi, welcome to Building Linux Distributions for Fun and Profit. I'm super excited about giving this talk at DebConf today. I wish we could all be together in person, but 2020 is what it is, so here we are. Many of you know me, but this talk will go out into the world, so if you haven't met before, hi, I'm Marga. I'm a Debian developer and a software engineer working at Kimfolk, which is a small startup based in Berlin, focusing on Linux and Kubernetes. This talk is a collection of my experiences working with Linux for the past 20 years. I'll first tell you about how my career with Linux developed, working at small and big companies, as well as being a Debian developer for 15 years. Then, I will try to summarize the lessons I've learned throughout this time. My experiences and my opinions are my own, but I'm hoping we can all learn from them. So, let's start at the beginning. I grew up in Buenos Aires, Argentina, where I studied electronic engineering. If you haven't heard of this degree, you can think of it as a mix between electrical and computer engineering. Professionally, though, I always worked in IT. I started as an IT support technician and then moved on to software engineering, system administration, site reliability engineering. I installed my first Linux distribution in the year 2000. This was a Mandrake installation. If you haven't heard of Mandrake before, that's okay. It hasn't been around for a long time. But Mandrake wasn't for me, so a few months later, it got replaced by a shiny new Debian Potato installation. And I've stuck with Debian since then. For a couple of years, I worked as a Java developer for a consulting company. As I was running Linux on all of my home computers, I managed to convince my boss that I should also run Linux on my work computer. But I was still working mostly with proprietary software, so that wasn't making me happy. So, in 2003, I quit this job and joined the IT department at my family's company. This was my first job doing Linux. At this company, we were deploying Linux installations to all users, replacing legacy proprietary software with open source software. This company was pretty tight on money, so we were the paragon of scrappy. The computers that we deployed on the network were mostly thin clients. These were old, used machines that would be considered useless by most people. But we gave them a new life by running a very small Linux OS on them that would just control mouse, keyboard, video, and network, and run an X server. And this X server would then connect to a more powerful machine that was running all the X client applications. This way, we only needed one powerful machine per 10 or so thin clients. This allowed us to deploy computers to many more users than would have been possible with standalone workstations given our tight budget. An interesting fact is that some of the users that were getting these thin clients hadn't had any workstation before. In fact, I recall one person telling me with pride that they had never used a computer before, like at all. The upside of this was that people didn't care about Linux or Windows. We taught them how to use the system to do what they needed, and that was it. The downside was that when something went wrong, the reports were usually not very helpful. One typical complaint was, "It doesn't give me access." And this could mean anything. Maybe the keyboard or mouse weren't working. Maybe the network was down, and so the connection to the X client failed. Maybe the login screen told them that their password was wrong. So really, it could be anything. Anyway, we kept deploying more and more thin clients and some standalone workstations as well when the users needed more processing power. And we ended up deploying 300 to 350 computers. And at the time, I felt like a lot to me. I was really proud of how I was adding more Linux users to the world. I didn't feel like we had our own distro. We were just using Debian. But looking back, we basically had all the traits of the Debian derivative, except for a cool name. We had our own internal repo where we kept a few packages, forked packages that had patches applied that were not in Debian, or packages that were not in Debian at all, or maybe even packages that we had developed specially for our needs and were not relevant for Debian. We also maintain our configuration in Puppet, keeping all the customizations in sync throughout the fleet. So yeah, we basically had all the traits of a Debian derivative, and it's a bit of a philosophical question, don't you think? Where does customized Debian deployment end, and a Debian derivative begin. Anyway, it's not really the subject of this talk, so let's move on. I've been talking about Debian a lot, and I mentioned I'm a Debian developer, so how did I get there? I started using Debian at the end of the year 2000. With time, I became more and more involved with the distro. By 2003, I considered myself a Debian bug reporter. I took great pride in creating good bug reports with clear reproduction instructions, log, and so on. That was my way of contributing back to Debian, and I was happy with that. I didn't want more. But then in 2004, a couple of life-changing events happened. The first one is that I got married. And those of you who are recurring DebConf attendees know that Maxi and I have gone through our Debian journey together. And then we went to DebConf 4 for our honeymoon. This was definitely a life-changing experience, maybe even more than getting married. Up until DebConf 4, I saw Debian developers as some sort of elite geeks that were kind of superhuman, completely out of my league. I felt that maintaining packages was such a difficult and complicated task that I wouldn't be able to do it. I was already sending patches to bugs, but I felt that that was the maximum of what I could do for Debian. But then I met all these awesome people. They made me feel welcome. They valued my input. They explained how things were not so complicated. They became my friends. And so when I came home, I was a different person. I wanted to become a Debian developer. I no longer thought that maintaining packages was reserved for elite hackers. So a few months later, I started maintaining my first package, and the following year, I officially became a Debian developer. Of course, I didn't do this on my own. The Debian Women project in particular helped me a lot at the beginning. The people in that group made me feel that I belonged, encouraging me to keep learning, keep growing, and getting more and more involved. Once I was a little bit more settled, I helped others get started as well, which was also very satisfying. The packages that I maintain for Debian have mostly been around things I cared about or needed. I started with some electronics related packages that I needed for university and either were not available or orphaned. Later on, I picked up different stuff as I needed it, like the Cinnamon desktop environment, which was the default desktop environment at Google. But let's not jump ahead. I'll tell you more about that in a bit. Throughout the years, I've done many different things for Debian. In particular, I enjoy fixing bugs. So for a while, I spent significant amount of my free time fixing release critical bugs on other people's packages. I also helped organize a few DebConfs. In particular, I was part of the main Orga team for DebConf 8 in Argentina and DebConf 15 in Germany. And I'm currently the chair of the technical committee, which sometimes I find hard to believe. I think back to those days in Porto Alegre when I felt like I was the only human being among a bunch of superheroes, and it's amazing how my journey has been. Anyway, back to my professional life. I worked at my family's company until 2012 when I moved to Munich to work for a team that maintains the internal Linux distribution used at Google. There's actually more than one internal Linux distribution at Google. My team was in charge of the one used by humans in their workstations, not by containerized applications running in servers in the data centers. Obviously, moving to Google was a huge change. One thing that was very different was that new hardware was not an issue. All users got beefy workstations, and they could even refresh them after a few years, just because the hardware was old. Took me a while to get over the shock from this. To be fair, lots of Googlers are conscious about waste and won't really refresh their hardware until they actually need it. But still, the fact that people could replace a perfectly working machine just because it was old was bonkers to me. More mind-blowing was the size difference. In my previous job, we started an IT area with 2 people, and it had grown up to 5 people by the time I left. And as I said, we were in charge of 300, 350 computers. So we had less than 100 computers per team member. After 9 years working there, I knew all the computers by name. I knew who used which computer. I knew the keyboard layout. I knew if the mouse had issues. I even knew the internal IP address for most of them. At Google, my team of 12 people was in charge of tens of thousands of computers. While the team grew a bit over time, the amount of hosts on our fleet grew a lot faster. At any point in time, we had more than 5,000 computers per team member to care for. This meant that it was no longer possible to know the hosts by name. And more importantly, that everything needed to be automated. Not just the obvious, like managing configuration with Puppet or having automatic upgrades, but also things like automated health checking and log collection. On top of that, we provided a bunch of tools and documentation to help users deal with issues themselves without needing to contact our team, including being able to reinstall their computer without having to fill a single prompt. And automation is not enough if it's not complemented with robust and thorough testing. In my team, we had a pretty thorough test suite that verified that a lot of the different use cases worked as expected. This allowed us to push changes to the fleet on a weekly cadence without panicking that we would break everything. Another difference was that at Google, there were a lot of teams maintaining different parts of the stack. My team was in charge of the Linux platform, but there were a lot of other teams providing software on that platform. And an important part of what my team did was enabling them to do that. This meant that some changes needed to be coordinated across many different people, across many different time zones. And finally, one difference that I really enjoyed was that our users were technical people, many of them also using Linux at home. This meant that bug reports were usually pretty good, including reproduction cases, and sometimes even a patch to fix the issue at hand. No more, it doesn't give me access, but rather good technical reports. Well, mostly, of course, nobody's perfect. Putting aside these differences, there were many things that were the same. When asked what I did before working at Google, I would reply that mostly the same, just as a much, much smaller scale. In both cases, we were keeping a repo of packages on top of what the distro provided, managing the configuration with Puppet, keeping all our changes and configuration in version control, enabling our users to do our job, and all of this using a distribution that was based on Debian. Well, sort of. The team I joined in 2012 was called Gubuntu. It was a Linux distribution based on Ubuntu that followed the long-term support releases. Right when I joined the team, my team was going through the migration from Lucid to Precise. A couple of years later, I was the one leading the migration from Precise to Trusty. And I mentioned our fleet had tens of thousands of computers. So you might imagine how big an effort it was to migrate such a large fleet from one LTS to the next. We had tools to help us with that, but even then, it was painful. Too many things had changed in between. Lots and lots of things needed to be fixed before we could get the new release out. A lot of effort got spent on getting the fleet updated, only to have to do the same thing all over again 2 years later. So after going through this painful migration twice, I convinced my teammate and other interested parties that we didn't want to keep doing that anymore. Instead, we should switch to a rolling release model where packages got updated progressively. We would no longer have a huge jump every 2 years, but rather small increases every week. And what better target to follow than Debian testing? Well, I don't know. Other people might disagree with that last part, but I convinced the power that be that this was a good idea. So we decided to stop tracking Ubuntu LTS and track Debian testing instead. In 2017, we renamed our team and our product to GLinux. We migrated the fleet from Trusty to Stretch, or kind of Stretch, because as we were working on it, Stretch got released and it became faster. And we kept tracking it and it kept changing. And I'm not going to lie, there was a lot of work involved here, and not all of it was easy or fun. But in the end, when Buster got released as stable, GLinux users at Google had received the updates progressively without having to actually do any manual action whatsoever, just as part of the normal weekly release process. All of this was super fun. I learned a lot and grew a lot in the almost 8 years that worked at Google, but eventually it was time for a change. So earlier this year, I took on a position at Kimfolk. As I mentioned, Kimfolk is a startup based in Berlin. It's a small company that is based on working on open source software with a focus on Kubernetes, Linux, and everything that has to do with containers. In my case, I've been focusing mostly on the development of Flatcar Container Linux. If you haven't heard of Flatcar before, it's a container-optimized OS based on CoreOS, which was another container-optimized OS, which itself was based on Chrome OS, which was based on Shento. Yes, Shento. Moving to Kimfolk was again a big change for me. The thing that impressed me the most was the speed at which one could get things done. At Google, time is measured in quarters. A medium-sized project might take 1 quarter to get planned, then another quarter to get a prototype out, then another quarter to get this into beta, and then finally one last quarter to get this into GA, which is a buzzword that means general acceptance. Working at a startup, there's a lot less red tape, less inertia, less stakeholders, so things just move faster. You can measure how long a project will take in weeks, and sure, timelines might slip a bit, but still a lot faster. The other big change was that while I was still working on Linux, I moved from working on a distro used by humans to a distro used by containers. There's a lot of differences there. The big one is how security weighs against usability. With any software out there, there's usually a struggle between security and usability. You need things as locked down as possible while still allowing you to get things done in a reasonable amount of time. And when security and usability clash, you need to make some hard choices. I found that the choices made for GLinux were different than the ones made for Flatcar. One example of this is the read-only user partition. In Flatcar, as in Chrome OS and CoreOS, the /user partition is read-only. You can't install new software on it. There's no package management system of any kind. The OS image stays exactly as it is. You can still customize things in Etsy and sideload software via containers, but you can't install new programs in /user, nor can you tamper with the programs that are already installed. For a human user, this might be really limiting. But for an OS that's used to run containers on it, as long as the necessary tools to run these containers are installed, this might be exactly what you want. All right, so here we are. I've taken you on a quick journey through my career as a Linux engineer. I started as a young, inexperienced techie, and through time and effort, I became an old-timer. Now, my goal with this talk was not just to admit how old I am, but to share lessons I've learned with you. So let's get to that. As a software engineer, system administrator, site reliability engineer, I love automation. Automation is what enables us to do interesting things with our time. We can automate the boring stuff and move on to do something that's a little bit more challenging. But there is such thing as too much automation. How can we tell? Say it takes you 5 minutes to write a script that will save you 1 minute of manual work. In this case, it makes sense to write the script if you're going to do this task more than 5 times. But what if it takes you 2 hours to write the script that will save the same 1 minute of manual work? The math is simple. It only makes sense to do this if you will apply the script more than 120 times. This example is rather obvious, but unfortunately, in real life, we usually don't know how long things will take to write the automation, nor how many times we will execute it until it becomes obsolete. Still, we can try to use some rough estimates, knowing that they won't necessarily be accurate, but they can help us decide how we spend our time. When faced with a boring task, some of us will start thinking how to automate it before we even complete the first manual run. So if you're in that camp, it's a good idea to ask yourself, how long do I think it will take me to roughly write and debug the script that will automate this? How much time will it save? And how many times will I use it before it's obsolete and I need to rewrite it from scratch? If, after asking yourself all these questions, the math tells you that you should spend time writing the automation, then by all means, go for it. Automation is awesome. Now, let's illustrate this with an example from my experience. Handling upgrades is a challenging task that I had to deal with at all of my jobs. The kind of automation applied is different because the operations and sizes involved are different. At the small company in Argentina, we were tracking Debian stable. So whenever there was a new stable release, we would start by upgrading an unused test machine, followed probably by our own workstations, followed by the computers of people that for some reason needed the tools first. Throughout this process, we would document any issues that we ran into, creating a script that took care of most of the work. And then we would move on to applying this script to the workstations of people that were on vacation, which would help us find any bugs in our scripts. And finally, we would spend a weekend or two upgrading all the other machines. So these scripts I mentioned automated the most common basic steps, but they were optimistic scripts, which means that if while upgrading anything broke, it was up to the person doing the upgrade to figure out how to fix it. It just wasn't worth creating a script that would take care of all the possible problems. Handling each and every problem would have taken way longer than the amount of manual work involved, multiplied by the times these problems would have surfaced. At my job at Google, this of course wouldn't work. There just wouldn't be enough weekends in the year to upgrade all of the machines in the fleet. Back when I joined in 2012, the main way of upgrading from LTS to LTS was to reinstall, and it was done by the users themselves. As I mentioned earlier, the install itself was fully automated. The user just decided when to do it, and the machine would get re-imaged. Users would be asked to reinstall their machine with the new LTS during a time period, and would lose access to the network resources if they failed to do it before the deadline. But reinstalling their workstations with the new LTS was not popular among our users. So during the transition from Lucid to Precise, one of my teammates started a project to develop an Inplace upgrade that would let users upgrade without reinstalling. As this was an experimental tool, not everybody used it, but it did get some traction. When the migration to Trusty came around, this script got improved, and we released it as an official way to upgrade, and plenty of users used it. And it got around 95% success rate in upgrading the machines without any manual intervention, which is quite good given how diverse our fleet was. Finally, when we moved to a rolling release based on Debian testing, the Inplace upgrade tool got improved even more, and it was able to handle the migration from Ubuntu Trusty to a moving target of Stretch and Buster, also with more than 95% success rate. This was 3 years later, so not only was a bigger jump in the software stack, the fleet had grown significantly. And this with a fleet of machines where users were allowed to install all kinds of different software. So yeah, it was no easy feat to get to that 95% plus success rate. It was possible thanks to the script being extremely pessimistic. It expected that any actions it took could fail, and ways to recover from these possible failures were in the script. It included code to fix the most common problems, but also when an unknown error was encountered, it had a bunch of different healing techniques to attempt to get the machine back into a working state, kind of like a broad spectrum antibiotic. And it was not just this extremely pessimistic coding. It wouldn't have been possible to achieve these high success rates without a ton of testing. We had a battery of automatic tests that ran the Inplace upgrade from different initial trusty states to whatever the current state of the rolling release was, so that if something that worked stopped working, we could detect it before it reached any users. And finally, the tool included automatic reporting of what it had done. This allowed us to investigate any unsolved failures and add whichever solution we found for them to the battery of fixes that it applied. Every morning, we could look at the dashboard of updates done the previous day and check if any of them had ended in failure. Looking at the logs and information collected by the tool, we could try to solve issues like weird dependency problems or file collisions or whatever. And these solutions could get incorporated into the next version of the tool. Unless the package management was out of commission, the affected users would then be able to update to the latest version of the Inplace upgrade and rerun it. The tool was able to restart from where it had left off and get the machine successfully upgraded. Of course, developing this tool took quite some time, several quarters time of a few different engineers. And as I mentioned, it took 3 iterations to get there. But by allowing users to upgrade their machines in place, my team saved these users the time that they would have spent on reinstalling any custom software or reapplying their custom settings if they had started from scratch. Given the sheer number of users, even if you estimate only a couple of hours saved per user, the total amount of hours saved is huge. I don't have the numbers, but one of my colleagues had calculated roughly how much they had saved, and it was significantly more than what had been spent on developing the tool. My point with this long story is to show how the effort spent on automation pays off when the numbers are big enough. When the fleet I was in charge of was 300 computers, it made sense to have a simple, optimistic script that would save us most of the work, and then we would fix any one of problems manually. With a fleet 2 orders of magnitude larger, it made a lot more sense to spend time developing robust automation because the time saved got multiplied by a much larger factor. Now, the case of Flatcar is pretty different. As I mentioned earlier, Flatcar uses one of the main ideas behind CoreOS, which is the read-only user partition. Not only that, it actually has 2 user partitions, user A and user B. When a new release comes around, it's deployed on the partition that's not currently being used. When the machine reboots, it tries to boot on the new version. But if for some reason this new version fails, it falls back to the previous partition, that one that was known to be working before the reboot. So it's not like there are never problems with upgrades, but whenever there is a problem, the machine keeps working by reverting to the previous version. This minimizes breakage and is completely transparent for the user. I don't know how many hours were spent by ChromeOS and CoreOS engineers on this mechanism, although I'm sure it was several quarters of quite a few people. What I know is that this has saved tons of time of many different users because these users just don't have to spend hours trying to recover from a bad upgrade that breaks their machines. This just doesn't happen. So I mentioned a few times that we need to decide how we spend our time and whether spending time in automation is worth it or not. This is one of the most important skills for people in IT in general that we need to learn to deal with, managing priorities. So let's talk about that. One of the things that I've learned in my different jobs is that there's always more to do than time allows. You are never going to get to the bottom of the backlog because new things that have more priority will come around before you have time to do them. I mean, I've heard from people that claim they are idle and bored in their jobs and have nothing to do, but in my experience and the experience of others working in the IT industry that I've heard from, this mostly doesn't happen. There's just too much stuff to do, too many bugs to fix, too many features to add. So we need to learn to prioritize. In a business that's trying to make a profit, the priorities are generally going to be driven by whatever brings in the money. Back at my job in Argentina, the first priority was to have the invoicing system online. If invoicing wasn't working, anything else had lower priority. If there was a new government regulation that needed to be in place in order to generate invoices, and this being Argentina, it wasn't a rare thing, we would drop everything and make sure that worked. And after invoices, bug fixes, and features got prioritized according to how much they would influence the bottom line. As my IT team was in charge of anything IT related, we had to do this balancing job for all the staff regarding system administration, software engineering, and user support. At my job at Google, I was thankfully far removed from invoicing, but still we needed to deal with a huge backlog and struggled with priorities. In that team, usually the criteria for what priority to give to different issues was related to how many people the issue was affecting. Was it 1% of the fleet, 5%, the whole fleet? Of course, it was not the only criteria. If the issue was making a team of 10 people completely unable to work, it would have a higher priority than if it was only mildly inconveniencing 100 or maybe even 1,000 people. One thing that we struggled with was laptop-related issues. If you've dealt with laptops running Linux in the past, you probably know that they can have a myriad of different hardware issues. Maybe the Wi-Fi driver doesn't work. Maybe the fancy touchpad doesn't respond correctly. Maybe the laptop drains the battery at a high speed while it's suspended. Or worst of all, maybe it comes with this horrible 2500 display that is higher than HD but lower than 4K and looks horrible when running GTK applications. And if you're wondering, yes, all of those problems were things that we had to fix throughout the years. So fixing these issues takes time and expertise, and sometimes you're not even sure that you will be able to fix them. So this can get really frustrating. In our case, laptops were a small part of the fleet, and so sometimes it felt like a bad investment of our time. But we had taken the explicit decision of supporting these Linux laptops, and that meant they were a priority regardless of the fleet size. Working with the Flatcar team now, the issues that we have to deal with are pretty different. But still, we need to find a way to prioritize what to work on. As Flatcar is container-oriented, enabling users to run their containerized workflows and supporting more cloud platforms both get high priority. But security trumps everything else. One thing I learned throughout my journey was that even if I agree with the person reporting the issue that it's a bug and it should be fixed, it's better if I'm upfront about the fact that I just won't get to it. If someone files a bug report about a problem they encountered and I respond saying, yeah, this is a bug, we should fix it, and then put it at the bottom of the backlog and never get to it, that someone isn't going to be very happy. If instead I tell them that it's totally a bug and I understand their frustration, but unfortunately I won't have time to solve it because there are other things that are higher priority, it's almost certain that they will understand and thank me for my honesty. The user can then figure out how else to solve their problem without waiting for a fix that will never come. This is a skill that takes time to master, or at least it took me time to master. Admitting that I won't be able to do something feels like I'm not good enough. When it's just recognizing that there's only so many hours in the day and so much time that can be done in that time. Some people summarize this as patches welcome, which works, but it's kind of short and it might be misunderstood as passive aggressive because some others have used it that way. I prefer to be a little bit more verbose and make sure that the other party understands what I'm trying to say. All right, so I've covered dealing with priorities at work. What about Debian? Debian's motto is that we are the universal OS. We aim to create an OS that serves everybody, not just end users, not just system administrators, everybody. This is really nice, but it's also really hard. How do you set priorities? Which use case is more important when you have to make a choice? This is an unsolved conundrum. It's basically left to the maintainers of each package to decide, which means that we have thousands of different people making 1,000 or more different decisions because they might apply different priorities to different packages. Sometimes maintainers will pick one default that they consider sane and possibly document how other use cases can be implemented. Sometimes they would just not make a decision and force users to make the decision themselves. I believe this is possibly the reason why there are so many Debian derivatives. Debian is great as a basis for creating a specialized distro because options are not forced upon you. You can choose what you want to do with it. But most users don't want to spend the time making those decisions themselves, which makes it hard to use it as is in large deployments. Someone needs to be the one applying the customizations to make the distro work out of the box. In the description of this talk, I promised that I would talk about the relevance of the OS in the years to come. Of course, I'm no fortune teller. I don't really know what the future would bring, but there are tendencies, and we can talk about those tendencies. It's possible that you're old-fashioned like me, and you would prefer that things stayed like they were 10 years ago. But it's just not going to happen. The tendency is that Linux distributions are becoming less and less important. Over the past 10 years, installing libraries and modules outside of the main OS became the norm rather than the exception. There's PyPy that Ruby gems, and Node.js ships separate packages for everything, including how to check if a number is even. But it's not just about programming languages. This tendency to ignore the underlying distro means that a growing number of programs come with their own package management system for extensions or plugins. This includes a wide array of programs like Firefox, Cinnamon, and Vim has like 4 of them. So including their own way to install add-ons has some advantages. For example, it avoids the bottleneck of packages getting ingested by the distribution. Everything just goes faster. And it abstracts installing these add-ons from the underlying distro. It doesn't matter if you have to use apt or yum or whatever, because you just use their own package management system. Of course, there's a reason why Linux distribution exists in the first place, so bypassing them comes with disadvantages. There's less or no quality control. There's less or no security updates, in particular for older versions. And there's no integration with the rest of the system. In other words, by making it super easy for users to install the latest flashy thing, it also makes it super easy for them to install random, buggy, insecure, or even malicious software. But users want the flashy things, so they will mostly ignore these concerns. The next step on this trend towards making distributions less and less relevant is running some form of contained applications on top of a thin layer of the OS. The contained applications could be Docker container, snaps, flatpaks, or what have you. I remember back in 2015, I attended a talk by a Docker developer who showed how she ran each of her graphical applications inside a separate container. Back then, this sounded rather over the top. Today, this sounds normal. I do this myself for applications that I don't trust. Running everything inside containers has a bunch of bad consequences, which could probably fill its own talk. Personally, the thing that worries me the most is security, because you need to make sure that all the software inside those boxes is updated. On top of that, there's also disk and network load. Most people don't care. It's 2020, why should we care about a few hundred megabytes of wasted space? I feel this excludes people that are in less privileged parts of the world where network and disk space are still expensive. And it's also wasteful. Transmitting and storing this data uses valuable resources that could be used for something else. And again, even if you and me don't like this tendency, it's here to stay. So we need to deal with it. Instead of ranting about how all these millennials don't know what it was like to install Debian from boot floppies, we need to figure out how to keep enabling our users to do what they want and keep our distribution relevant. How can Debian provide value in this new containerized world? There's a bunch of things we can do once we stop denying reality. And I don't claim to have the answers here, but I might have a few suggestions. For example, we can make it easy for users to update the contents of their containers. We could perhaps have some system managed containers and then have tooling like upgrade containers that take care of upgrading everything inside these containers. We can also provide tools to manage like these different arrays of like snaps, flatcars, Docker, etc. in the system, or keep track of where things got installed from. So if a user used PyPy or npm, keep track of everything and then make sure it gets updated as necessary. And we could also make it easy to save space by avoiding repeated code. And I know that shared libraries is the answer, but it's the old answer and it's less relevant in the current world. So maybe we can help deliver something like shared libraries, but for containers. I don't know what the answer there is, but maybe someone in the audience does. So if you are thinking about this, maybe it's time to start your own project. Something that we could do to make it really easy for users to generate minimal images for systems would be to allow to not have all these essential packages, which are not necessarily essential if what you're going to run on top of that is a frozen system. So if you're not going to install packages on your Debian image, you don't need apt. You maybe even don't need Perl. And these are just some suggestions. I'm sure you can come up with more. I don't believe I have the actual answers to the problems at hand, but I do know that if we want to keep Debian relevant, we want to keep delivering value to our users, And we need to start thinking about this hard and now. Thanks for listening. I hope you enjoyed it, and I'm now ready to answer your questions.
So the first question in the Etherpad is, what happened to the Linux distro at Google, to GLinux? What's the state now? So I'm no longer working at Google, so I can't tell for sure, but the last I've heard, it's still being used, still tracking, Debian testing, sort of. Of course, like, problems happen, but as I heard, it's still on track. Okay. Talkmeister, do you want to ask me the second question?
All right, sorry about that. So the next question was, okay, what is this? Technique was supported via CoreOS, and it's now supported by Red Hat. Do you know if there's something similar that we can run on Debian to get Kubernetes or another platform?
This is a slightly small product. Kimfolk, the company that I work at, also has Kubernetes product similar to Tectonic, except it's all open source because Tectonic was not all open source. And it's called Locomotive with a K. And it's not Debian. It uses Flatcar for the OS in the containers. I do not know of any system that uses Debian. In particular, as I mentioned in the talk, Debian would need to make some steps in order to become a little bit more immutable to make it a good OS for running Kubernetes on it.
Thank you very much. The next question that we have is, what kind of quality assurance for weekly release?
So I mentioned a little bit about this. We had a test suite that ran on hardware, on actual hardware, and virtualized machines as well. It included a lot of different tests for a lot of different use cases. And so every time that we would put out a release, it would go through this test suite and only go out if all the tests passed. If a test failed, then we would investigate what was the problem. Sometimes it was that the test needed to be fixed, but most usually it was that something in the software stack was broken, and so we got that fixed.
Okay, thank you. Let's see, we still have a few more minutes. The next question is there anything in Linux infrastructure that you wish would be available as software?
Yeah, so this is a hard question because, yes. There's a lot of things that we use at the GLinux, in the GLinux team, in our infrastructure that I wished could be available as free software. This testing infrastructure that I mentioned that was harnessing all these different machines. And one of the systems I wrote was the system that orchestrated ingesting new badges into the system, like packages from Debian testing got built and then tested. And then if they passed all the tests, they got into the next release. And one of the problems that makes it hard to release this kind of software is that it's very much intertwined with internal Google technologies that are not free. So even if that code could be free, it wouldn't work without this whole stack of non-free software.
Okay. Thank you very much. It looks like we might just take one last question.
Okay.
Okay, most have already been answered. Maybe we can quickly read over there. What means using a container theme? Do you use it on workstations?
Right. So I do not use Flatcar on my workstation. I use Debian. I've heard of people that use container optimized OSs in their workstations or laptops. And in that case, it would mean that absolutely everything that you're running is container. And so this can work, but it takes a lot of effort. And while it's possible, and maybe for someone that is geeky enough, it's a fun project, it's not it's not the intention of the OS. The OS is to be used in a server to run containerized applications. So you're kind of pushing the limits, and for that reason, you're going to have a rough time. But again, if it's something that's fun for you, that's great.
Thank you very much for the well-delivered, well-prepared talk and for the penguins. And perhaps if we still want answers for the other questions, you can see them on the pen. Thank you.
Thank you very much. Bye-bye.